Well, thanks so much, Susan and Patrick, for the invitation. And thank you all for attending. I'm really excited about the opportunity to tell you a little bit about some of the work we're doing in my lab at the University of Virginia. I want to begin by explaining how I came to be studying questions about communication and agency in autism. So one of the major inspirations for the research I do has been a community engagement seminar on autism that I taught a few times at the University of Virginia called The Science and Lived Experience of Autism. Here you can see pictures of 3 of the cohorts, and each year a group of 20 undergraduates and about 10 college-aged autistic young adults participated in this seminar where we learned and laughed and got to know each other a little bit. And the undergraduates and I got a chance to learn about autism alongside the people who are living it. Down here in the corner is Elizabeth Vossler, who is my collaborator in that endeavor. And my experience in this teaching the science and lived experience of autism led me to really question a lot of conventional scientific wisdom about autism and really shaped my research program in a number of ways. For example, one topic that was raised repeatedly by the autistic students concerned their desire for social connection. As you probably know, one of the oldest, most widely held beliefs about autistic people is that they're not interested in social interaction. And so one line of my work has focused on this erroneous belief. But that's not what I'm going to talk about today. I've told you that our community partners were college-age autistic folks, but what I didn't yet mention is that they are also non-speaking autistic people. So about 30% of autistic people cannot communicate effectively using speech. This includes folks who don't say anything, individuals who might repeat words and phrases, and some people who speak a bit. Non-speaking people can and do communicate effectively in a lot of other ways, including body language, for example, but they can't communicate effectively using speech. They can't readily share information, thoughts, beliefs, memories, and so on in a conventional language-based way. We don't know why. It's not because they lack the motivation to communicate. I don't think it has to do with cognitive limitations. I think the most likely explanation has to do with the motor challenges that most non-speaking autistic people face, and which involve difficulties in planning and executing intentional movements. And if you think about it, speech is the finest of fine motor abilities, and the vocal apparatus has to be coordinated perfectly to produce intelligible speech. Well, traditional approaches that attempt to provide non-speaking autistic people with access to communication are limited in a number of ways. One commonly used approach is the picture exchange communication system. It involves laminated cards with icons or pictures that can be used for requesting things. For example, a picture of a cookie could be exchanged for an actual cookie. The idea is that over time and several stages of training, the individual would learn to be able to sequence icons in the end to be able to make comments and even to ask questions. Unfortunately, however, very few individuals actually progress beyond the requesting phase. And even if they do, this communication system is obviously limited in that the vocabulary is chosen by someone else. I should mention that PECS-like systems have also been created for tablets and iPads, but they have many of the same limitations. Verbally based interventions are also common. Here, one underlying assumption is that lack of speech is caused by reduced levels of motivation. As you already know, I don't subscribe to that camp, but these verbally based interventions often use motivating objects to encourage children to speak. If the kid wants the cookie, for example, they would have to make an approximation to the word cookie. Turns out that these are also not effective for most non-speaking folks. In fact, a recent review of the only 2 randomized control trials focused on communication interventions for non-speaking kids concluded that neither of the interventions resulted in maintained improvements in spoken or nonverbal communication for most children. So most non-speaking autistic kids and adults are never provided access to an effective form of language-based communication, despite undergoing years or decades of interventions like those I've just described. So I said that a group of non-speaking autistic students participated in this university seminar I was teaching, and that we discussed autism among many other things with them. How did those discussions take place? Well, these folks all communicate in writing. They've learned over the course of many years and guided by parents and professionals to point to letters on an alphabet board, like the one you see down here, held vertically by a trained communication partner or assistant. They're all working on being able to type independently on a keyboard, but they are not there yet. I want to show you an example of what this looks like. The video you're about to see is of a 22-year-old who began to learn to use a letterboard about 6 years before this video was taken. She has limited ability to use speech. If you met her and said hello and introduced herself, she might respond with a stock greeting and her own name, but she would not be able to use speech to respond to a question like the one you'll see here. Have you ever experienced uncertainty? The other thing you should know is that even though she can't use speech effectively to convey her thoughts, she's reached a point in her practice of this communication method where she calls out the letters even before she touches them, and sometimes she'll say a word after she's pointed to all the letters in that word. She's wearing a camera that allows us to record her movements from her perspective, and I'll be telling you more about that in a second. And she was asked in the course of a conversation whether she experienced uncertainty.
Have you ever experienced uncertainty?
V-E-R-Y, very, O-N-E, everyone. D-O-E-S-I-M-N-O-D-I.
Keep going. D-I.
F-F-E-R-E-N-T. Different.
So she spelled, everyone does, I'm no different. Many people have dismissed the possibility that non-speaking autistic individuals who've learned to communicate in the way you just saw are actually conveying their own thoughts. They believe that it's the assistant who's actually the author of any text produced, that the assistant holding the letterboard somehow leads the user to point to particular letters. For example, maybe the assistant moves the board a certain way to signal a particular letter, or maybe they're moving the board underneath the user's finger until it reaches a particular letter. I think really what this position reflects is a disbelief that someone who can't talk, who is autistic, who moves in unusual ways, who acts in socially non-normative ways, could have sophisticated thoughts like, everyone experiences uncertainty, I'm no different. Indeed, a question that's frequently asked is if non-speaking autistic people have such sophisticated thoughts, why is an assistant needed to help them at all? Why can't they just type it out on their own? And the short answer is that there are non-speaking autistic people who can type independently. Some of them are on this call, but it's not something that happened overnight. It required years of practice and assistance. So we have folks like those who participated in my seminar who are working on the skills needed to be able to communicate independently, but who currently do so with assistance. Critics contend that we shouldn't believe that they're conveying their own thoughts because it's possible that they are somehow being cued by the assistant which letters to point to. So we set out to investigate how plausible a cueing explanation of letterboard users' performance was. To do this, we measured how quickly and accurately they looked at and pointed to letters as they responded to several questions. To set the stage for why speed and accuracy are relevant to whether letterboard users are being cued by the assistant to point to certain letters, I have to give a brief primer about something called Hick's law. So bear with me. Hick's law is a well-documented constraint on information processing. It says that the amount of time it takes to make a response increases as the number of cue response alternatives increases. So let me give you an example. Let's say there are two buttons in front of you, labeled A and B, and you undergo some training to learn that when a green light is illuminated, that would be the cue, you should press the A. That would be the response. And if a pink light is illuminated, you should push the B. Later, after you've learned these associations, when you see the pink light illuminated, it'll take you about 250 milliseconds to correctly press the B. Now suppose that in that initial training phase, you're presented with 10 buttons instead of 2, each of which is associated with a different cue. So during the training phase, you learned that, let's say, the red light is associated with the letter F, and the pink light is associated with the letter E, and so on. Now, when you're presented with a pink light, it'll take about 500 milliseconds, or half a second, to press the correct button. That is, it takes about twice as long as it took when there were just 2 cue response alternatives. And that is Hick's law. Response time increases as a function of the number of cue response alternatives. And it's useful to take a step back and ask why. Well, it requires 3 things. It requires detecting the cue, retrieving which response goes with a particular cue. And of course, it's going to take more time cognitively when there are 10 possible cue response alternatives than when there are 2. And then the participant has to execute the response correctly, which also will take more time when there are 10 possibilities than when there are 2. So how is this relevant to letterboard users? Let's take the case of Everyone Does, I'm No Different, the video you just saw. If the speller were being cued to the letter E, the assistant would have to deliver a cue that disambiguated which of the 26 letters the user was supposed to point to. And then the user would have to detect, decode, and act upon that cue. And this sequence of events would have to be repeated for each letter pointed to. And each of these steps, the delivery, detection, decoding, and acting, would take time and would be subject to error, particularly if there are 26 possible letters to select, 26 cue response possibilities, if you will. So if letterboard users were slow, or if they made a lot of errors, this would be consistent with a queuing account. But fast and accurate spelling would not. So in the study I'm going to tell you about now, we quantitatively characterized 9 experienced letterboard users' performance in the wild, investigating how quickly and accurately they look at and point to letters as they're spelling. These were young adults between 15 and 26 years of age who had been using a letterboard for a few years, a minimum of 2. And importantly, all of them had been in all kinds of interventions prior to the introduction of the letterboard, including speech therapy, where the focus was traditional speech, as well as other forms of AAC, ABA, occupational therapy, and so on. Parents reported seeking out training in the letterboard when other forms of communication were not effective for their children. But importantly, these other methods and other therapies were not stopped when these participants began learning to use the letterboard. The data were collected as participants took part in a session that lasted about 20 minutes. The session was designed to simulate what happens in individual sessions at the center where the data collection took place. So the assistant would read aloud from a prepared lesson and stop at certain points to ask questions, and then invite the user to respond. Our goal in this initial work was to try to characterize the phenomenon as it actually happens in the wild in an everyday situation. This same kind of approach has been used about the cognitive processes underlying skills like piano playing, golf, driving, and so on. We collected head-mounted eye tracking data as these individuals participated, so we could investigate how their patterns of gaze, where they looked, were related to their spelling. So the basic question is, where are they looking as they spell? We used a pair of glasses with 2 cameras attached. One camera captures the central field of view of the user, and you can see that in the inset down here. And the other camera is pointed toward the eye, and it captures an image of the eye. After the session is finished, we can run these 2 videos from the 2 cameras through some software that calculates where the user was looking on each frame of the video. And you can see that in the inset here. in the frame from one of these post-processed videos, this red dot, which I'm circling, shows where the software has calculated the user is looking. Just to give you a sense of what this looks like, I want to show you another clip. This one with eye tracking data included, it's represented by this red dot. So in this first frame, you can see the user is both pointing to the letter W, and the red dot is on the letter W, meaning that he's looking at that letter. This participant is a man who is 26 at the time the video was taken. What I want you to notice is how the red dot precedes his point to each letter, meaning that he's looking at each letter before he points to it. He's chewing gum at the time the video was taken, and the voice you hear this time is of the assistant. But in the course of a conversation about having to wait for things, he was asked to name something that he'd had to wait for.
W, A, I, T, I, N, G, waiting, F, L, R for M, Y, my, D, R, E, A, M, G, I, R, L. Waiting for my dream girl.
Waiting for my dream girl. It's always a little tricky to show video over Zoom when the audio and video may not sync, but the clips are also available from the paper, which is freely available. So from these videos, the research assistants can code in a frame-by-frame manner to identify what letters are pointed to and when, and what letters are looked at and when. So I'm going to give you an abbreviated presentation of the data. The full data are available in the paper. So let me tell you first about the pointing data. Over the course of their 20-minute session, participants spelled answers to 24 questions. And in doing so, they pointed to, on average, over 300 letters. And over 90% of the letters they pointed to were correct in the context of what they were spelling. They rarely made spelling errors. In terms of timing, how long it took participants to, in this case, get from the letter L in their point to the letter I, it was about 1 letter per second. So participants were very accurate in their pointing, and they were moving along at a pretty fast clip. Turning to data from the eye tracking, we can ask how often they looked at letters before pointing to them. So here you can see in this frame, the participant is both looking at the one on the left, and I'm circling. The participant is both looking at and pointing to the letter L. In the middle frame here, you can see that the red dot representing where the participant is looking has reached the letter I. And then in this final frame, the finger has caught up. So if participants were just holding their finger out as an assistant moved the board beneath it, you would not expect that they'd look at a letter before their finger made contact with it. And in fact, the average percentage of letters that were looked at before being pointed to was over 70%. You can see there is some range here. Details are in the paper, but we conducted some simulations that showed that even for the participant who's at the low end of the range here, he looked at letters before pointing to them more often than you would expect if he were just randomly looking at letters on the letterboard. When participants looked at a letter before pointing to it, as is the case in this example, how much time was there between the end of the touch to the last letter, so in this case, the end of the touch to the L, and when the look began to the letter I? It was about half a second. And we can ask, once they looked at the next letter in a word, how long did it take for the finger to catch up? That was also about half a second. So participants looked at most letters about half a second after they pointed to the previous letter, and about half a second before pointing to the next one. We also identified 2 patterns in the pointing and gaze data, which, when they're observed in studies with non-autistic typists, studies that are done for entirely different reasons, these patterns have been attributed to the cognitive processes underlying fluent spelling. So specifically, participants were faster to look at and point to letters within words than letters between words. in non-autistic typists, this kind of finding is interpreted as reflecting planning for the production of the next word. And we also found that participants were faster to look at and point to more common letter pairs compared to less common letter pairs. So they were faster to look at and point to the letter E when spelling the word hello, for example, than to look at and point to the letter E when spelling jello. And that's because HE in succession is much more common in English than is JE. And again, in non-autistic typists, this finding is interpreted as reflecting the internalization of orthographic or spelling regularities. So putting it all together, participants in this study made few spelling errors, pointed to about one letter each second, looked at the next letter about half a second before pointing to it, and the patterns in their reaction times were similar to those that have been documented in non-autistic typists. From these data, we argued that a cueing account where the assistant delivered a subtle cue and participants detected, decoded, and responded for each letter they pointed to is implausible, given what we know about constraints on human information processing. Instead, these data suggest that participants were looking to and pointing at letters they selected themselves. In short, participants showed communicative agency. And these findings are consistent with what you would expect if the participants were conveying their own thoughts. For these participants, the letterboard is an effective method of communication. It enables them to share information in a way that other methods they have tried for years and decades have not. It's effective in that it gives them access to educational, social, and community opportunities they would not otherwise have. I need to be clear that we're not making claims about everyone. This was absolutely a unique sample of experienced letterboard users. So I'm not claiming that all non-speaking autistic people can learn to convey their thoughts using this method. But our findings demonstrate that the blanket dismissal of assisted autistic communication is not warranted. There's much more work to be done, of course. Some of the things my group is working on in collaboration with autistic folks and their families include investigating questions about the development of literacy in non-speaking people and about how technology like augmented reality might be used to support communication. This is in collaboration with engineers at the University of Calgary. Let me conclude by returning to the seminar I taught at the University of Virginia that helped to inspire this work. As we learn more about autism, particularly from autistic people themselves, I think we're also learning how little we understand about it, and that many of our assumptions about autistic people are wrong. I want to thank the autistic and non-autistic students in the seminar for helping to move autism science in a progressive, data-driven direction, while never forgetting about the lived experience, and also to thank the participants in the study for their willingness to participate, and the research assistants in my lab, particularly Andrew Howe and Sydney Cadogan, for doing the careful coding of the data that I presented you today. So I'll stop there, and I'm happy to answer any questions, and of course, to continue a conversation offline as well.
Wonderful presentation. Thank you so much, Vikram. We're going to feed you now some questions from the Q&A. We're a little bit over time, but we've got a break coming up next, so I think we're in good shape. Patrick, go ahead.
Yeah, I see a lot of questions in here about letterboards and also about the role of the assistant or facilitator. And here's one that merges both. This person is wondering if to eliminate doubts about facilitated communication and other similar techniques, what about having the letterboard converted to a tablet to replace the assistant?
Yeah, so as I mentioned, all of the folks who I know who communicate in these ways are absolutely working toward independent communication. And one of those methods could be using a tablet or a typewriter, probably not a typewriter, or keyboard. But they're not there in their practice yet. Several are well on their way. But at this point in the practice, and as I mentioned before, there are folks who started out with a great deal of support in their efforts to communicate in these ways and now are independent. So I think that's something that most non-speaking autistic people who communicate in these ways are working towards, absolutely.
Great, so we have another question in the Q&A. Do you anticipate that next steps would be to include eye tracking or touch-based error correction into the technology so that the user can engage in this type of communication independently?
Yeah, another really good question. Some people have asked, well, there are products available for people, eye tracking products available for people who with communication support needs. And why didn't the participants in my study ever just make use of that? Well, the short answer is probably because they are non-speaking autistic people, that technology was never offered to them. I think it's something that should be explored. And it's also another kind of technique that my understanding is actually takes a fair amount of time and practice to learn how to use effectively. There's good research having nothing to do with communication specifically that suggests that using your eye to isolate targets is a really effortful activity. Doesn't mean it can't be done, it absolutely can be, but it would take time and effort to learn how to do so in an effective manner.
The UC Davis Mind Institute was founded in 1998 with the promise to reduce and prevent the disabilities that can be associated with autism and other neurodevelopmental conditions. Every day, our clinicians and researchers make progress on that promise. Our groundbreaking research on autism, Fragile X syndrome, chromosome 22q11.2 deletion syndrome, ADHD, and other conditions associated with disability are helping affected individuals achieve their fullest potential. Please visit our website or our social media platforms to find out more about current studies, upcoming events, and how you can help make a difference.